This is a supplement to lessons 3 and 4 from Unit 8, the Pythagorean Theorem and Irrational Numbers. And in this supplement, what I'm showing is forming a single square that has an area of 2 square units, and then looking at where the side length of that square falls along a horizontal axis. And so that side length is the square root of 2. So where is that placed on a horizontal axis, or you can imagine that being the x-axis. First, look at this table that has the length of the side of a square, then the area of that square, and then the length of that side based on the square root of that area. So, the length of the side of a square is 1 unit. The area is 1 times 1, or 1 square unit. And so that length of that side is the square root of 1, or 1. So it's 1 square unit, and the length of the side of each side actually is 1 unit. And if you jump ahead to 2 units, the area is 2 times 2, or 4 square units. So here they are right here. 2 times 2 is 4 square units. And the length of this side, one of these sides, is the square root of 4, which equals 2. And then if the length of the side is 3 units, the area is 3 times 3, or 9 square units. So 3 times 3 is 9 square units. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the length of one of these sides is the square root of 9, or 3 units. Now what's going on with the areas in between 1 square unit and 4 square units? There has to be a square that has an area of 2 square units. So the length of that side is going to be the square root of 2, which is going to be somewhere between 1 unit long and 2 units long, because it's this square that's getting a little bit larger and a little bit larger until it has an area of 2 square units. So that length has to be somewhere between 1 unit and 2 units. It's the same with an area of 3 square units. The length of the side has to be somewhere between 1 unit and 2 units. And likewise, for the area of squares that are 5, 6, 7, and 8 square units, those lengths have to be between 2 units and 3 units. Each of those squares is growing a little bit larger until it has an area of 5 square units, but its length along the side is going to be between 2 and 3. So each of these has a length between 2 and 3. They're increasing until finally you reach an area of 9 square units, and that has a length along the side of the square root of 9, or 3. So once again, the square root of 2 is approximately this value. The square root of 3 is approximately this value, both of them between 1 and 2 units long. The square root of 5 is 2 point something. Square root of 6 is 2 point something, a little bit larger. 7, 2 point something, a little bit larger. 8, 2 point something, a little bit larger, until we get to 3 units, which has an area of 9 square units. Now we're going to focus on the square root of 2 right here, and we're going to get an answer that is very close to 1.414, and this number, just like pi, continues on forever and ever. So here are 2 squares. Each square has an area of 1 square unit. Now they are divided up into 16 smaller pieces, or 16 smaller squares, but what I want you to think about is that the area of this square is 1 square unit, and the area of this square is 1 square unit. So this length is 1, and this length is 1. So now if I take these 2 squares and combine them into a single square, that single square is going to have an area of 2 square units. So I'm going to move these 4 pieces over here. I'm going to move these 4 pieces along this edge, and so this length along this axis here will eventually have a length of the square root of 2, because this area of this square that I'm building has an area of 2 square units. So I have one piece that can go here, and so now I have 7 small squares left over. 1, 2, 3, 4, 5, 6, 7. And what I can do is take those 7 squares and divide them up among these 10 squares here, or these 10 Yeah, these 10 squares. This gets a little bit hard to follow, but just keep going. This is 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. We'll get to this last square up here in the corner in a few minutes. So I'm going to take these 7 squares and divide them equally among 10 squares. So that means that each one of these squares is going to get 7/10 of the area. So each one of these goes into these 10 squares. And so this length along this edge right here is 7/10 of this square, because I divided these 7 squares among these 10 squares. Now notice what the length along this edge is here. It is 1 unit plus another. This length is 1/4 of a unit. This is 1/4 or 25/100ths, 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 1 whole unit. So this is 1 and 25/100ths. And this length to this point right here would be 1 and 5/10ths, or 1 and 50/100ths. The thing to understand, though, is that the length along this side, which is going to be the square root of 2, is going to be greater than 1 and 25/100ths, but less than 1 and 5/10ths. Now, to complicate it even a little bit more, this length is actually 7/10 of 1/4, because remember, this length right here is 1/4 of 1 unit. And so this is 7/10 of 1/4, and that is 175 thousandths, or 0.175. Now that length is going to get added to 1 and 25/100ths. And this gets a little bit confusing, and we're just making a better estimate by understanding the fractions and the decimal values. Now, to make matters even a little bit more complicated, we have to fill in this 1 square at the top here, because we haven't built our 2 square unit square. So the way we're going to do that is we're going to shave a little bit off of each of these pieces and put them into this square right here. So not very much, just a little bit. And all you have to know then is that this length is going to be less than 1 and 25/100ths plus 0.175. So it's going to be less than that. So this is 1 unit. This is 1 and 25/100ths unit. And this is the 0.175 out to this pink line right here. But the square root of 2, or the length along this square that has an area of 2 units, 2 square units, is going to be a little bit less than 1.425. And so remember where this comes from. Remember what we're trying to do. The square root of 2 is equal to approximately 1.4142, and it goes on forever and ever and ever. So if I take this as the length of this side of the square, and I square it, 1 and 425 thousandths squared is a little bit more than 2, because this length is a little bit more than 1.4142. It's 1.425. So this is an estimate of the square root of 2 that we know is a little bit more than the square root of 2. Now remember, we're looking at a square that has an area of 2 square units. So if I get rid of this, all this stuff, this is 1 square unit, and this is the second square unit that comes from this square. We moved all these pieces over to here. Get rid of everything. This area of this square is 2 square units. The length along this side is going to be a tiny bit less than 1.425. We know that our target is the square root of 2 is very close, which you get when you use a calculator, is 1.4142. That was tough. So we're going to do the same thing 3 more times, where we're going to take 2 square units and transform these 2 square units into a single square that has an area of 2 square units. In this case, each square has 25 smaller squares. So 5 times 5 is 25, whereas before each square had 16 smaller squares. So we should get a better estimate because we have more squares to move around. So here are 24 of those 25 squares used to make that one square that has an area of 2 square units. We have one small square left over. So we're going to take that one small square and divide that among 14 squares. So this is 1, 2, 3, 4, 5, 6, 7. And up here at the top, 1, 2, 3, 4, 5, 6, 7. So each of these 14 squares is going to get 1/14 of this single square. And 1/14 is equal to 0.0714, and this number keeps going on forever and ever. So here they are. And so that means that this length along this square is 1/14 of this square. Now remember, this square is 1/5 of 1 unit. So this is 1 unit along this edge, or along this side, and this square is 1/5 of that. So this length right here is actually 1/14 of 1/5 of this unit length right here. So it's very small. It's 0.0143, or 143 10,000ths if I stop at the 10,000ths place. But this length is going to be a tiny bit less than this 0.0143 because we have to take a very tiny part of each of these pieces and build this one last remaining square in the top right corner, but it's very small. So all of this is going to lead to a much better estimate of what the square root of 2 is equal to. And so this length along this side is 1 unit plus 1/5 plus another 1/5 or 2/5. That's equal to 4/10. So now we're up to 1 4/10, and we're going to add this very tiny piece here, which is 0.0143. Add those together, get a total of 1.4143 units. But remember, the square root of 2, which is the length along this side, is a little bit less than this length, because we had to shave off just the teeny tiniest piece to build this single square up here. So if we take this value and square it, you get an answer of 2.0002, so out to the 10,000ths place. And so our estimate is just 1/10,000th off of what you would get using a calculator. So that's pretty close. So let's get rid of everything. So remember that this is a single square that has an area of 2 square units. Get rid of everything. This is 1 square unit. This orange around the outside is a second square unit, so 2 square units. And this length along this side is a little tiny bit less than 1.4143. And you use a calculator, you get 1.4142. Okay, so let's keep going. So here are the 2 unit squares, but now there are 36 smaller squares. It was 25, and before that it was 16. Now it's 36. So the same idea, let's combine those 2 unit squares into a single square that has an area of 2 square units. And so if I take as many pieces as I can to spread them around this square unit, I'm left with 8 of these small squares left over. And I'm going to spread those 8 small squares across 16 squares. So it's 8 this way, and it's 8 this way. So that's 16 total squares. So that means that each of these squares is going to get a half of one of these squares. So I take these 8 squares, divide them up, and here's a half for each of those 16 squares. Now, this length right here is 1/6 of a unit. And this is 1/2 of that 1/6. So 8/16 is the same as 1/2. So 1/2 of 1/6 is equal to 1/12. So this length right here, just half of this, is 1/12 of this entire 1 unit length. Now we have to shave a little bit off of this. We have to complete this square up here. Take a little bit off. So that means our estimate of the square root of 2 is going to be a little bit less than this length from here out to here. The square root of 2 is going to be a tiny bit less than that total length. So that total length is 1 unit plus 1/6 plus 2/6. 2/6 is the same as 1/3, which is the same as 4/12. They're all the same. And that's 1 and 1/3, which is 1.333333, and it continues. And now we're going to have to add this 1/12 right here. Add them together and you get a total of 1.416. Now the square root of 2 is going to be a little bit less than that. It turns out that this is not as good an estimate as before because we have too many pieces left over that we have to divide up. So it just leads to not as good of a estimate of the square root of 2. And so if we take this amount and square it, 1.416 squared, you get an answer of 2.005. Still pretty close to 2, and we're only 2 thousandths off, but before we were just 1/10,000th off. So this is 1.414, this is 1.416, so that's 2 thousandths more. And before, if you remember, we were 1/10,000th more, so that was a better estimate. So if we get rid of everything, this is 1 square, which has an area of 2 square units. This is 1 square unit. This is the second square unit. Get rid of everything. So this length out to here for the square root of 2 is going to be a little bit less than 1.416. And it's actually 1.4142 and so on. So one more time. So now we're going to divide each of these unit squares up into 100 smaller squares. So this should lead to a very good estimate. And so the idea is, as we keep chopping these unit squares up into more and more smaller squares, we should get a better and better estimate. And you reach a limit finally, if you keep going infinitely, eventually you will arrive at the value for the square root of 2. But it never ends. It keeps on going, just like pi. But that process, reaching that limit, or figuring out what that limit is known as calculus. So here are as many of these smaller squares spread out around this single square unit. You're left with 4 of these small squares to chop up and spread evenly among 28 of these squares. So now we're getting to very small pieces. So 4 divided up among 28 small squares equals 1/7 of each of these squares, 1/7 of a square for each of these squares. So it's a very small amount, it's 0.143. So there's those pieces spread out across 28 squares. So this piece right here is just 0.143 or 143 thousandths of this square right here. So now remember that this length right here is 1/10 of a unit. So this is 1 unit length. This length right here is 1/10 of that. And this piece right here is 1/7 of that 1/10. So now we're working with very small values, which is going to lead to a much better estimate of the square root of 2. So this is 1/70th, which is 0.0143. 143 10,000ths. But our estimate is going to be a little bit less than that because we have to chop off just the tiniest amount of each of these squares to fill in this one single teeny tiny square up here. So now we can add everything together. This is 1 unit, 4/10ths of a unit, plus this piece right here, 0.0143. So you get a total of 1.4143, and this number continues forever, but the square root of 2 is going to be a tiny bit less than that. So if you take that amount and square it, you get 2.0002. So this is 2/10,000ths, and our estimate of the square root of 2 is just 1/10,000th more than what you get with the calculator, out to the 10,000ths place. So this is 1 square, which has an area of 2 square units. This is 1 square unit. The orange, once again, is 2 square units. And this length out here is the square root of 2, but it's a tiny bit less than 1.4143. It's 1.4142. Now there is a way to graph exactly, to locate exactly the square root of 2 on a number line, the square root of 3 on a number line, the square root of 4 on a number line, using the Pythagorean theorem. And that's where this unit is going. The title of the unit is the Pythagorean theorem and irrational numbers. So if you use the Pythagorean theorem to figure out this length, and then just use that as the radius of a circle, this length right here is the square root of 2. And then you can continue in this pattern. This length is the square root of 3. This length is the square root of 4. And the square root of 4 is 2. So that's a check that we're doing the right thing, because this is 2 units. This is 1 unit to right here, 2 units to right there. I don't know if the authors will use this, but there are ways to graph exactly, precisely on a number line, irrational numbers.